before we start this week's video for IM2, there are a few like vocab terms or words that I think would be very beneficial for you to know before heading into this video. So firstly is the zero product property. So the zero product property is just when we get one side to zero when factoring. So for example, if we had the equation 2x plus 5x plus 2 is equal to 3, using the zero product property, we would get one side to 0. So we would choose, I would hope you would choose this side. So we're going to subtract both sides by 3 to make this side 0, which would get us to x squared plus 5x plus, oh man, -1, or you could just say -1. Yeah, -1 is equal to 0. So that right there is a zero product property, just like getting one side to 0. And this is a way that we can solve for quadratic equations. It's just by setting one side to 0, aka using the zero product property. Yeah. Now, the second one is, you know what, I'm going to do this in a different color, because why not? Oh, I like that brush. Okay. So, now the second one that would be great to know is inverse operations. Okay, so you can't see the S, but there's an S there. Inverse operations. And so what I mean by that is that when you're solving, you're going to want to be using inverse operations, specifically for like taking square roots, which we will get like into later into this video. For example, if we are multiplying something by 2, let's say 2x, the way we get x by itself is by doing the inverse. So we're going to divide by 2, which will get us to x equals 1. And that will get x all by itself. Another example is, let's say if we're doing x plus 2 is equal to 0. Okay, that's where our zero product property comes in. Look at that. We're going to use an inverse operation. So instead of adding 2, we're going to subtract 2 by both sides. That's going to get us to x is equal to -2. And once again, x is by its lonesome. So it's literally just like inverse opposite. Like that's really all we need to focus on right now. Okay guys, for this equation right here, we're actually going to have to use the quadratic formula. And if you don't have that memorized, you probably should eventually, but for right now, I'll just give it to you. So the full like equation is x is equal to -b plus or minus the square root of, oh my golly, square root of b squared minus 4ac, and that is all over 2a. That is the quadratic formula. You will most likely want to have all of this memorized. Now, I referred to these variables in the quadratic formula as either A, B, or C, right? And so what exactly are these variables, right? So A just refers to the first term, well, the coefficient of the first term, B refers to the coefficient of the second term, and C represents the coefficient of the third term, which in this case is just 5. So, firstly, before we can even begin, we have to get this whole equation to equal 0, right? But as of right now, that's not the case. So what we're going to do is we're going to subtract the 7 on both sides, right? Because whatever you do to one side, you have to do to the other to make this side 0. And that will get us to, to 3x squared plus 10x minus 2. Which is, let me move that around, which is equal to 0. So now we can actually start using our quadratic formula. I'm just going to rewrite that real quick. Okay, so I cleaned this up. Now, we have to figure out what our A, B, and C's are. So A, like I said, is just the coefficient of our first term, so it's going to be this guy right here. So A is just going to be equal to 3. B is the coefficient of our second term, so it's going to be equal to 10. And C, what color is C? Oh, C is blue. Okay, C, it's going to be this little guy right here, -2. So now we can plug this all into our quadratic formula, which, like I said, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's plug that all in. Yeah, I'll do it on this side, actually. So b was 10, so it'll be a negative 10. So it's negative 10 plus or minus, because that's our b, right? Then we're going to have b squared, so that's 10 squared, minus 4, that 4 just stays there, a, which is 3, and c, which is negative 2. And that is all over 2a. A, once again, is 3. And now we're literally just going to solve for that. We're just going to simplify this whole thing. So it's going to be, okay, negative 10 plus or minus 10 squared, that's 100. This whole thing, I already did it over here, but that would just be positive 24. So plus 24 all over 2 times 3, it's 6. That gets us to 6. Wait, let me just go back. If you guys don't know how I got this, 3 times negative 2 is negative 6. Negative 6 times negative 4, 24. Okay, plus 24 all over 6. And that just becomes, negative 10 plus or minus the square root of 124 all over 6. Now that we're left with this little guy, right here, there's actually a way we can simplify this even more. So right now, I'm just going to focus on the square root of 124. So we're going to move over here. So when we're looking at the square root of 124, the square root of this is not going to be a pretty number. So what we want to do is that we want to simplify the radicals. So what that technically means, now the radical literally just refers to this whole thing as a whole, if that makes sense. For example, that's the, this right here, this is the radicand. This is the radical symbol. I didn't spell that right. That's the radical symbol. Just pretend I spelled that right. But yeah. So as you guys know, each part of this has its own little, has its own name, if that makes sense. But when we're talking about this whole entire thing, it's a radical. So now that we have these factors, right, we can actually write this in a different way. We can write this by saying the square root of 4 times 31 is the same thing as the square root of 124, right? But we can actually write this even simpler. This can also become, right, square root of 4 times the square root of 31. That is the exact same thing as saying the square root of 124. And the reason for that is because we can literally just split it up into its factors, right? This is the same thing as this. But what we know is that this little guy does not have a perfect square, right? He does not. You cannot just square root this and have a nice pretty number. But what you can square root and have a nice pretty number is 4. So an even simpler way to write this is simply by saying 2, because the square root of 4 is 2, times the square root of 31 is equal to the square root of 124. These two things are literally the same exact thing. So now, from this equation, we can rewrite this as, let's pick out a different color, guys. Pick yellow. Okay, we can write this out as negative 10 plus or minus 2 times the square, 2 times the square root of 31 all over 6. And that is our final answer with the radical simplified. Okay, guys, this is the equation that we are solving now. So firstly, obviously, we're going to use the zero product property, meaning we are going to get one side to 0. So, you know what? What color am I feeling? I do like this pink. We haven't used pink. Okay, sorry, got distracted. Anyways, so we're going to use the zero product property, meaning we're going to get this whole side right here. We're going to get it to 0. How are we going to do that? Using inverse operations, so adding 3. Sorry, guys, I don't know what happened right there. Okay, so it's going to be 6x squared minus 13x plus 6 is equal to 0, right? We finally got that side to 0. Now, on this section, okay, so we finally got this side to 0. So in this section, what we're going to do is we're going to try to solve this through factoring or guess and check. I personally am a big fan of factoring instead of guess and check. So yeah. So I actually really like using these boxes. I know a lot of people aren't the biggest fan of them. I'm a big fan just because it helps me really visualize like what I'm trying to get at. So what I know is that I need something that's going to multiply to 6, right? And all I know for now is right here, whatever is here and here has to multiply to make 6x squared. And the things that are here and here are going to have to add up to make this negative 13x. I know this might seem a little bit confusing right now, but we will get there. We will get there. So really all we're trying to do is we are eventually trying to get an equation that looks something like this. If that makes sense. And so if you want to, like, if it helps you visualize these that are going to be right there, it's going to be like the same thing that's right there, if that makes sense. I hope we're going to get there. If you can't see it right now, don't worry, we'll get there. So what I'm first going to do is I'm going to look for factors of 6's, because funny thing, like these are both 6's, so we're going to just find some factors. So we have 6, we can split that up into 1 and 6, 2 and 3, and that's really it. So one way, like that, this is really just like kind of solving a puzzle, right? So what I know is that both of these sets of factors will multiply to 6, correct? But some of these factors also are going to have to go up here and up here, right? So if you can't really see it right now, what we're trying to do is we just know these two have to have an x right now. That's all we know right now. But we don't know what their coefficients are. And we don't know what these values are right here. So right now I'm going to try, how about let's do this. Let's do 1 and 6. So I'm going to do 1 here. Actually, let me use a different color so you guys can like really see that. So we're going to do 1 and then we're going to do 6 here. So if we try to solve this, and I'm just going to use the same ones for these little not factors. Okay, so I'm also just going to like use the same numbers up here. So I'll put 1 here and 6 here. So what this is saying is that 1x times 6x, yeah, that totally makes 6x squared, right? We know that. Now 1 times 1. Now 1 times 1 is 1. And 6 times 6 is 36x. Oh, I forgot that x right there. Now, this is where we get into a little bit of a pickle, right? What we're seeing here is that, yes, it multiplies to get 6x squared and 6, but these two right here, they actually add up to make 37x. And 37x is definitely not what we have right here. So from this, we can tell, yeah, these are definitely not the numbers that we need. So I'm just going to like erase all of this. Okay, now let's try again. So, and I hope you guys know I'm like doing this wrong on purpose. Trust me, guys. I know the answers. Okay, so we know, of course, it's going to multiply to 6, and this is going to multiply to 6x squared. So what we already know is that this is going to have an x, and this is going to have an x as well. Now, I'm going to go ahead and try just like a different set of factors. I'm going to try 2 and 3. Now, I know like the last example that I did, I showed that like these and these had to have the same factors as well as these and these. Those can have completely different like numbers. Like the only reason I'm doing it the same is because it happens to be a coincidence that they're both 6. Like that just happens to be the question. So for this one, I'm going to use I'm trying to think, right? So something also that went wrong with the last one is that this guy right here is a negative, right? Negative 13x, which means like this guy is a negative, correct? Well, yes, it's a negative. And this right here is a positive, which means our numbers have to add up to make a negative and multiply to make a positive. So what does that mean? Is that our two numbers up here are going to have to be like, they're gonna have to be negatives. Okay, so we're gonna try doing the 2 and the 3x, right? We're gonna have that as our coefficients because we know that's gonna multiply to get us to 6x squared. Now, the little tricky part comes in figuring out if this one is gonna have the 3, this one's gonna have the 2, or is it gonna be 2 and 3? You might not think it matters. It very much matters, right? Because what we eventually need, okay, I don't know why I didn't erase this. What we eventually need to get to is a negative 13x, right? We need these guys right here to add up to negative 13x. So, how are we going to do that? Well, we can kind of already figure out that we can also do like trial and error once again. So, if we plug in 3 right here and 2 right here, this right here is negative 4. This is negative 9. Oh, and look at that. That was genuinely like pure luck. I really just like plugged in those numbers. But right here, we can see that, let's go over here, negative 4x. Oh man, I keep forgetting these x's, guys. Please do not forget your x's. Don't do what I'm doing. Okay, so what we can see is that negative 4x plus negative 9x, that gets us a negative 13x. And where do we see a negative 13x? Bam! And let's check just to make sure. Negative 2, negative 3, that multiplies to make 6. 2x times 3x, that multiplies to make 6x. And then negative 2 and, yeah, positive 2 and negative 2 multiply to make negative 4x. 3x and negative 3 multiply to make negative 9x. And if we add these two together, we get negative 13x. So that is it factored out. But how are we actually going to write that? So we can now write that as 2x minus 3, parentheses, 3x minus 2. Now, I hope like you can now visualize what I was trying to tell you guys earlier, that like this right here was going to be the same thing as this right here. So yeah, we literally just like pop these guys over here and pop these guys over here. But we are not fully done, right? Now we have to get these x's by themselves. So we can literally just like split these up, you know, pretend they're like two separate things. I am going to erase this real quick. I don't think we need it. I hope not. Okay, so yeah. So we're going to have, let me do this in a different color. Okay. Let me use this little teal. I really like this teal. Okay, we're going to do 3x. Did I forget a symbol? Why is nobody telling me I forgot a symbol? Sorry, guys. Okay. Fix that. Okay, so we have 3x minus 2. And okay, so I'm using the zero product property. And now I'm going to try to get this x all by its lonesome. So firstly, I want to get rid of this negative 2 that is right here. And the way I'm going to do that is I'm going to use inverse operations. So I'm subtracting by 2. I'm going to add by 2. And whatever I do to one side, I have to do to the other. So we're going to add 2 on this other side as well. That's going to get us to 3x is equal to 2. But we're still not done. This x is still being multiplied by 3. So what am I going to do? I'm going to divide by 3. Divide both sides by 3. And x is going to be equal to 2/3. So we have this little guy done. Now we're going to move on to this one right here. So same idea, same concept. What we need to do is we need to use the zero product property to make this equal to 0. So 2x minus 3 is equal to 0. We got to get this x by itself. How are we going to do that? Use inverse operations. So how about this? We are going to add 3. Why? Because we're subtracting 3, so we should add 3. And whatever we do to one side, we have to do to the other. So add 3. So that is going to be 2x is equal to 3. And then we're still not done. This x is still being multiplied by 2. So we're going to divide both sides by 2. That gets us to x is equal to 3/2. So our final answers will be x is equal to 3/2 and x is equal to 2/3. Actually, let me do that in like permanent writing. Okay, so our final answer will be x is equal to 3/2 and x is equal to 2/3, which you can see right here and right here. Okay guys, so today we want to figure out how to get this little x all by itself, right? And this specific section is about how to like find this x by taking square roots. So firstly, we see that there's just this negative 5 hanging out there, right? So we can get rid of that real quick. The way we're going to do that is we're going to add 5. Right? The reason we're going to add 5 is because by adding 5, we can take out this negative 5, right? Negative 5 plus 5, these two cancel out, okay? So, before we can move on, you have to remember that whatever you do to one side, you have to do to the other. So, we also have to add 5 to the other side. And what I mean by other side is, I mean like what is on the other side of the equal sign. So, then we are going to have negative 2 x plus 1 squared is equal to negative 50. Okay, we still don't have x by itself. The next step that we can do is take out this times negative 2, right? So the way we can take that out is by dividing by negative 2. Actually, let me use a different color, guys. Okay, we're going to divide by negative 2. And the reason for that is because if you were multiplying by something, dividing by that same number is just going to cancel this out, right? We're just going to cancel that out. So then after that, we are now left with, let's go back to yellow. You're going to be left with x plus 1 squared is equal to positive 25, right? Because negative 50 divided by negative 2 is positive 25. Now, here's where it starts to get a little bit trickier. The main thing that's stopping us is this little squared, right? This like parentheses is being squared. So the way that we're going to take away or like cancel out this something being squared is by taking the square root, right? So if, let's say for example, x is being squared, the way we can take this out is by square rooting it, and that would just equal x, right? So in this scenario, we want to take out this like x plus 1 is being squared. So the way we're going to take that out, we're going to square root that, right? But what you do to one side, you have to do to the other. So we're also going to square root this. So on this side of the equal sign, we're going to get x plus 1, right? Because these two things cancel each other out. Now, what's going to get a little bit tricky. Alrighty, here's where it's going to get kind of tricky, right? Or, I don't know, possibly. So, the square root of 25 is both negative 5 and positive 5. So, we can actually write that as by using this little symbol. Oh, man. Okay, I'll use a different color. I like purple. Okay, so we can actually write it by using this little symbol. This just means plus or minus, as in like positive or negative. So the square root of 25 is actually negative 5 or positive 5, right? Because negative 5 times negative 5 gets you 25, because negative times a negative is a positive. Let me make that clear. Right? Or 5 times 5 is 25, because positive times a positive is a positive. So what that means is that x plus 1 is equal to plus or minus 5, right? Positive or negative 5. So now we can actually split this up into two different equations. We can now split this up into x plus 1 is equal to 5, or, well, not or, and x plus 1 is equal to negative 5, right? Actually, I don't like that. I don't want to confuse you guys. Let me change it to a whole different color. Okay, we'll do slow blue. So you see how it's plus or minus 5? So we can either do x plus 1 is equal to negative 5 or x plus 1 is equal to 5. So I'm going to focus on this red one right here. Like what we're going to do now is we're just going to get x by itself. So once again, we are going to subtract 1, because by subtracting 1, we can get rid of this positive 1. So subtracting 1.
Okay guys, thank you so much for watching this week's IM2 video. If you still have any lingering questions, don't forget you can either leave a comment, request a tutor, or ask your teacher. Please don't forget to like and subscribe so you never miss any of our uploads.
-1.
And that is it. See you guys in the next video.
So our final answer will be x is equal to 4. X is equal to negative 6. You could also just write it as like x is equal to 4 comma negative 6, as in saying like it's both of them, or just like by writing this. I personally just like writing it that way, but that is how we do it.